Minimization of DFA with multiple final states. We are having final states C, D and E. This is the transition diagram. We are writing transition table for this. A is the initial state. A of getting input 0 goes to B and A of getting input 1 goes to C. B of getting input 0, it goes to A. B of getting input 1 goes to D. C of getting input 0 goes to E. C of getting input 1 goes to F. D of getting input 0 goes to E. D of getting input 1 goes to F. Then E of getting input 0 stays in E. E of getting input 1 goes to F. F getting 0 and 1 stays here. 0 equivalence. For 0 equivalence, we are combining these non-final states into one set and final states into another state. Then we are minimizing this 0 equivalence to 1 equivalence. For 1 equivalence, we are checking this set. A of getting input 0 comes to B and A of getting input 1 comes to C. C stays in another state and B of getting input 0 comes to A and B of getting input 1 comes to D. D also stays in another set. So both C and D are staying in another set, but they belong to only one set. Belongs to same set. So we are combining A and B. Then F. F of getting input 0 comes to F. Again F of getting input 1 also comes to F. So we are separating this F and putting in the another set. So A, B, F and C, D, E. Then we are minimizing it to 2 equivalence. For 2 equivalence, again we are checking A. A of getting input 0 comes to B. A of getting input 1 comes to C. C belongs to another set. Then B of getting input 0 comes to A. A stays in the same set, but B of getting input 1 comes to D. D is staying in another set. But C and D are in the same sets. Then E of getting input 0 comes to E and E of getting input 1 comes to F. So we are mentioning E in E is also another set because it is final. Then this 1 equivalence and 2 equivalence both are equal. F even getting input 0 or 1 stays in F itself. So F is mentioned in the separate state. This 1 equivalence and 2 equivalence is equal. Once these two are equal, we are going to stop this and we are going to prepare transition table and DFA. For DFA, we have to combine, we don't have multiple states like NFA. So we are combining these two. We are having sets A, A of getting input 0 comes to B. B of getting input 0 comes to A. So we are combining this BA. So AB, we are mentioning AB of getting input 0 comes to AB, combining these two. Then again AB of getting input 1, A of getting input 1 comes to C, B of getting input 1 comes to D. We are combining this C and D. We don't have states as C and D. So we are mentioning here as C, D, E, this state. Then F. F of getting input 0 and 1, it stays in F itself. Then C, D, E, final states. C of getting input 0 comes to E. D of getting input 0 also comes to E. E of getting input 0 comes to E. Here we don't have separate state called E. We are having C, D, E combined here. So we are mentioning C, D, E. And C, D, E of getting 1. Everything moves to the same state. F, F, F. So we are mentioning F. This is the diagram for this. AB of getting input 0 stays in AB. Getting input 1 moves to CDE. CDE of getting input 0 stays in CDE. CDE of getting input 1 comes to F. F of getting input 0 and 1 stays in F itself.